If we need to elect a king about pigments, definitely chromium will be the king. The name chromium comes from the Greek chroma, color, because the compounds based on chromium, they have very strong, vivid colors, so that chromium got its name for colors. Periodic table, chromium is over here, number 24. So here we see the table with its X-ray peaks. We have number 24, chromium, we have K alpha 5.4 and K beta 5.9. As usual, we want to have a baseline. We start with a cube of pure chromium. Chromium has this kind of steel feeling. It feels like steel. From the analysis of pure chromium, we get this spectrum. We see a strong K-alpha line. We are in the order of almost 150,000 counts, very high. We are using the low keV setup. So again, we are using just a thin filter, aluminum, 0.25 mm. Let's now explore chromium in the context of pigments until 1950s, those contained in the pigment checker standard version. Chromium has been used a lot in art as an art supply, but just for pigments from the 19th century onward. This is the pigment checker timeline for pigments. You can download it from the Pigments Checker webpage. We start with the yellow that are down here. So we are magnifying this area. So we see that we have here chrome yellow 1816. So 1816 is the year when this chrome yellow was commercialized. Chrome yellow is a lead chromate, and the spectrum that we get is this one. So we see that in the same conditions, we are using the same low keV setup, we get a peak for chromium that is way smaller than that of a pure cube of chrome. The count basically here we see will be around 2000 counts. This means that we have to be careful in order to detect chromium, because the signal when we have these pigments based on chromium, this one is the most used, the chrome yellow, the signal could be very low. Consider that here we have 2000 counts and we are using the low keV filter setup that is optimized for these low keV elements. If we are using the routine filter setup, we can expect to have even smaller signal from chromium. Let's look at something else, moving onward in the timeline. Chromium could be used also to get green vivid color, and indeed in 1838 it was developed viridian. The formula is over here, is a chrome oxide hydrated, so has some 2 molecules of water in the formula. Then later on was developed chrome oxide green 1862, that basically is the same, is a chrome oxide but without the water content. Chrome yellow is the black one you see over here, about 2000 the counts. Now when we do chrome oxides, so viridian, this one, or this one without the water molecule, just chrome oxide green, we see the peak is much stronger, because of course in the formula we have just chromium, while in chrome yellow we have lead that will absorb most of the X-rays, so plays a big role. In this case, when we have just a chrome oxide, oxygen is transparent to the X-rays, we have just chromium, and the signal is much stronger. Let's move to the blue colors. Quite recently, in 1935, was developed cobalt chromite blue. This was intended as an alternative to the more costly cobalt blue. This is the formula. We have a cobalt chromite, it's the red one, and in this case you see basically the signal is the same of the lead chromite, the actual chrome yellow that you already discussed. Chrome, depending on the element that is linked in the molecule, gives a different color. So if it's mixed with lead, we have yellow, chrome yellow. If it's mixed with cobalt, we have a blue color, the cobalt chromite blue. Chrome is also used in modern pigments, not as much as for the old ones. Okay, chrome yellow is very present, and a lot of artifacts in arts, chrome green, absolutely. In modern art, there have been developed some pigments based on chrome, but they are not that much diffused. So the most important are this one, strontium chromate. This one is called strontium yellow. And you see again, chrome is mixed with strontium and we get this yellow, strong yellow. It is over here in the pigment checker modern art. So it's the black spectrum over here and has a strong signal. So we are about 10,000 counts. The other one is a chrome titanate, so this kind of orange color over here, and the signal is much less because chromium is present in the formula, but mixed also with antimonium and titanium, so it plays a smaller role. Therefore we have a signal that is smaller.